Okay, so we're supposed to do some stuff. Remember, you have a quiz tomorrow, so if you can, please watch the video just so that you're okay. All right, so sketch a graph. So basically, what we did today. So here's a graph. Over the course of 1 year, right? So let's start with January, February, March, April, May, June, July, August, September, October, no, November, December. The daylights, the hour daylight. So January, the daylight hours in winter are a little bit lower. So let's just start over here. Okay. And as February goes, right, daylight hours go up, up. March, April, May, June, and June. Was it July? June 22nd. July 22nd. That's the peak, and then it starts going down. I don't know if it goes down that drastic, but slowly start going down, right? So this would be daylight hours. And the daylight hours depend on the month that you are, right? So, and then it starts back again. So as we approach summer, right? Remember, we have more daylight hours in the summertime, and then we reach a peak the moment we June 21st or July 21st, we hit a peak. That's the longest day of the year, and then it goes down again. Okay. This is the ground as you ride a Ferris wheel. Okay. I'm going to write the distance on the ground, and as you go on the Ferris wheel. As you go on the Ferris wheel, so first of all, the moment you get in, your distance is right here, right? So you're sitting, you're not really on the ground stuff. You're sitting on that little chair, and you're this much off from the ground. And as the Ferris wheel turns, let me just draw a Ferris wheel over here, and here's you who just hopped in. I don't know how it, right? And then let me actually draw this way. So you hop right in over here. You're not, and this is the ground, so you're a little bit above the ground. So at position 0, right? Let's call this position 1, position 2, position 3, position 4, 5, 6. And as it spins, you go from here to here, to here, to here. And when you're over here, you're at the peak. So again, something like that. Okay. Your pulse rate as you watch a scary movie. Oh, okay. Ooh, that one's interesting. So here's your pulse rate. Here's the movie, right? The start of the movie, 0 minutes. Your pulse rate, I don't know, it's about 80. Right? So as the movie starts, it just started, and well, hopefully it didn't start by scaring you right off the bat. If it doesn't, let's assume it's here. And then there's a scary, your pulse rate could be the same, and it's scary. Something scary happens, it goes up, right? And then it could go up again, so it can go up, and then the movie goes along, and you're still scared, and it goes up, and then the scary scene goes over, comes over, it drops, right? And again, another scary scene comes up, and you can go up, etc. And then I don't know, your heart rate, you're what do you call, expecting something, and it might go up again, and then it's going to drop. So your pulse rate as you watch the movie could go up and down. It can go up, stay up, and then go up again, even higher if it's even scarier, etc. But it fluctuates up and down. Your energy level through a Monday school day. Okay, so that's obviously grammatically correct. Your energy level through a Monday school day. Oh my God. So your energy level, and that might vary with people. So this is Monday, your school hours. So at 0 minutes, the moment you walk into the school, your energy level, I don't know, might be over here. And then you go to math class, it could drop, right? And then you go to gym class, it goes up. And then you go to ELA gym class, it goes up. And then you go to ELA class, it might go even higher. And then social studies, you know, your energy level might be even higher. And then you go to science, no offense to whoever your science teacher is, and it might drop again, and so forth. And then you go to lunch, your energy level goes up again. So it could be an up and down situation. Okay. Runners 1, 2, and 3 on the car race describe what happens at times A, B, C, and D. At A for runner 2, well, at times A, well, so you can clearly see that runner 1 starts at a faster speed. So at time A, up to this section over here, right? So runner 1 starts fast. Runner 2 starts second fastest. And runner 3 starts the slowest. Maybe he's conserving energy, knowing that the race is going to be a long one. He starts nice and easy. And then section B, by section B, okay, runner 1, I'm sorry, let me just write this again. Runner 1, he slows down, right? Still increasing in speed, but slows down a little bit, but still increasing in speed. What happened to runner 2? Runner 2 definitely picked up the pace, right? Picked up the pace. If you can clearly see that runner 2 went from A to B. It sees the green line, picked up the pace, right? So he definitely increases speed. Runner 3 also picked up the pace, but not as much as 2, right? So you can tell. And then over here, now we go from B to C, right? And I'll write it over here. From B to C, let's see, runner 1 still continuing an increase, but again slower. Runner 2, he increases speed. Look at runner 2, he increases speed, and then he slowed down a little bit. He's still increasing his speed. So one continued. God, I hope you're not reading this. Continued a steady increase, a constant increase. Runner 2, what did runner 2 do from B to C? He increased fast, ran faster. And then he was still faster. He's still running fast. So he still increases, but ran faster. And then not as fast, but still increasing in his speed. Runner C, then the runner 3, you can tell that same thing. He continues increasing, but from this point on, from right here to here, right, his speed decreased a little bit. Again, still increasing it. 1 second. Hello. Sorry. And then from C to D, from C to D, right, in this section right here, what can we tell? Runner 1 finished the race. Sorry, my pen's not working too well. Runner 1 finished the race. As you can tell, he managed to go all the way here. So he started really fast, and then he continued at a steady increase here, right? Finished the race. Runner 2, he stopped. Runner 2 stopped at point C, so he didn't finish the race. And runner 3, what happened to runner 3? Runner 3, he was over here, so if you looked from C to D, from C he continued a little bit more. He continued a little bit more. and stopped. Maybe he just got really tired. Okay. Don't go too crazy over this. It's just as long as you understand that it's increasing or decreasing. Okay. Taylor is on the way to school describes what happens in section A, B, C, and D. Well, she's on the way to school, so this is velocity, right? And this is time. Well, let's see. From this point, right, she leaves the house, and then all the way to this, would say she's increasing. So she's running somewhere, right, at a fast speed. She's increasing. So from 0 to 30 seconds, she's increasing in speed. And then from this point right here to this point, her speed is constant at whatever that is. I can't see because I just really can't see. So we know that in section A, her speed, her velocity is increasing. In section B, her velocity is constant. And that's what I want you to know. Meaning that whatever this is, what is that, 80? 80 meters per second. From here, from this section here, she maintains a constant speed. And then from this section right here, the end of B, section C, her velocity is decreasing. And then in section T, she's still running. She's still, I don't know what she's doing, but in section D, she doesn't stop. Her velocity again is constant. Her velocity is constant. Okay. Yeah, that's about it for that section. Oops, sorry. No, that's not it. What happened? Sorry, it's the phone. I'm not going to pick it up. So here we have, it's just function notation that I want you to practice a little bit more. If you want to use a calculator. So what is the value of this function f at -3? So f of -3. So when it's -3, you're going to plug it in. 2 times -3 to the second power plus 2. And that's going to be 918. That's going to be, so f of -3 is 20. F of 6, well, let's plug it in. So f of 6, 2 times 6 squared plus 2. So when x is 6, y is going to be 32, 36, 72, 74. F of -1, so it's going to be f of -1. Let's plug it in correctly. Equals 2 times -1 to the second power plus 2. F of -1 is going to be 2 plus 2, which is 4. And the last one, f of 4, 2 times 4 squared plus 2, which is 16 times 6, 32 is 34. So, all right. All right, and then, yeah, that's it. So the bottom one, again, just the same repetitive thing, right? And they want the value of the function as particular x value. So when it's x is -5, what's g of x? So g of -5 equals -7 times -5 plus 4. G of -5 equals 39. When x equals 2, what's the value of the function? So g of 2 equals -7 times 2 plus 4. G of 2 equals -14, -10. -1, so g of -1 equals -7 times -1 plus 4. G of -1 equals 7 plus 4, which is 11. And then finally g of 0, that's the easy one. I love zeros. -7 times 0 plus 4, and that makes it very, very easy, which is just positive 4. Okay? Here's a table. Everything's done for you. So what is the value? So again, remember, this is where you put the x values, right? So when x is 1, what did you get for, what's f of 1? F of 1, when f is 1, the total y is 9. So that's basically what you're asking. What is this? Question mark? F of, sorry, that's an X. So f of 1, right here, what do you get? You get a 9. F of 3, right? And the value of this function is, the value of x is 3. What's the value of the function? Well, it's 17. Now here they have the backwards. When f of x is 13, right? When the value of the function is 13, what is it that we input? What number did we put in here to get 13? Well, and obviously that is 2. And the last section, write that as a function. So basically, we're going to change that. So number 1, in function notation, this would be f of, sorry, not f, it's h. H of x equals 2x plus 5. That's all we're doing. K of a equals 12a plus minus 9. And then last one, d of t equals 22t. Here, and again, y equals 2x minus 6. So f of x, right, this replaces the y, equals 2x minus 6. This one is m of n equals 25n minus 10. And the last one is going to be c of p equals p squared plus 5p plus 5. Okay, that is it.